right, today we're going to be doing lecture 29, Systems of Equations by Substitution. Now, when we have systems of equations, you're usually going to see them in standard form. You're usually going to see them in standard form. And a standard form is always going to be in that same form that we've always talked about, right? We're always going to have that ax plus by equals c. Ax plus by equals c. So this is standard form. And typically you're going to see every single equation in standard form like this. So when you have a systems of equations, you're going to have more than one equation at the same time. So you could have ax plus by equals c, or you could have something like dx plus ey equals f. So here I have two different equations. And what we're going to learn about today is we're going to learn about how to use substitution to solve them. So substitution is when you typically get one variable by itself. You could get the x by itself, or you could get the y by itself. And either way, you're going to figure out what x is or what y is, and then you're going to use it to substitute back into the other equation. So for example, if I take this first equation and I actually figure out what y is, I can plug that back into the second equation and then figure out what x is. So we're going to be looking at that today. So I'll leave this up there for a little bit and then we'll move on to the next slide. So today we're going to be looking at substitution, and on Wednesday we're going to be looking at another method that's different from substitution, but it can still solve the same types of questions. It's going to be called elimination. Okay, let's look at the problem set. We'll be looking at number 1. So number 1 gives us 7x plus 2y equals 0. And then we have y equals negative 4x. So here we have two different equations. And what we're going to do is, since the last one is already solved for us, we're going to use this one to plug back into this one. All right, so how would I do that? Well, I know that y is the same thing as negative 4x, right? So what I can do is I can go back to the original equation, which is 7x plus 2y equals 0. And I can replace the y with a negative 4x. So all I'm going to do is I'm going to replace the y with a negative 4x and go from there, while everything else stays the same. So all I've done is I wrote out the first equation exactly the way I see it. And then in the second step, I'm changing y to be a negative 4x because that's what the second equation tells me. Y and negative 4x are the same thing. So now I can go about it the way I usually go about it. I multiply by 2. So 2 times negative 4x is going to give me negative 8x. 7x minus 8x is going to give me negative 1x. And then I can divide by negative 1 to get my x by itself. And I get x equals 0. So now I know what x is. X is going to be 0. But I still have to figure out what y is. So now what I'm going to do is I'm going to use this, and I'm going to do what's called back substitution. Back substitution. Okay. So now what I can do is I can choose whichever one of my originals that I want. It could be the first original or the second original, but I usually choose the one that looks the easiest to me. So I'm going to choose the second equation, y equals negative 4x. Now I'm going to substitute what I got in for the last part. X is 0. And if I let x be 0, what happens? I get negative 4 times 0, which is 0. So now I know what y is. And I can write out my ordered pair. 0, 0. I know that x is 0. That goes right here. And I also know that y is 0. That's going to go right here. Okay. My final answer is always going to be an ordered pair. I'm always going to have an x coordinate, and I'm always going to have a y coordinate. Okay. Let's look at the next slide. Let's look at number 2. Here I have 5x plus 5y equals negative 5. That's my first equation. But under it, I have y equals 4x plus 9. So here what I can do is, I know that y is equal to 4x plus 9. So I know that y is the same thing as 4x plus 9. So I'm going to substitute that in for y on the top equation. So let's do that. My top equation was 5x plus 5y equals negative 5, right? Well, since I know that y is the same thing as 4x plus 9, I'm going to substitute that in for y. So I get y is 4x plus 9. I just substitute that in for y, always putting it in parentheses so I don't get it confused with anything else. And then I keep on going. Okay, so I need to multiply everything by 5 here. So I get 20x plus 45, and then I bring down my equal sign and my negative 5. And then I just go from there. So 5x plus 20x, that's going to give me 25x. Bring down my plus 45, and my equals negative 5. So now I'm ready to solve for x. I can subtract 45 from both sides. To get negative 50. And now I can divide both sides by 25. and I get x equals -2. Okay, so now I'm ready to figure out what y is. Once again, I can use whichever equation I want, either the top or the bottom. I'm going to choose the bottom. And I'm going to plug in what I got for the last part, x equals -2. So if x is -2, that means I can plug in -2. And I get y equals -8 plus 9. -8 plus 9 equals 1. So now I've got my y value. The last thing I do is, now that I have both of my variables solved, I can write my ordered pair. So I got -2, 1. Now, one mistake that I often see is that kids will get to this part, and then for some reason they'll stop. They won't figure out what y is, and they won't find the ordered pair. And if I see that, I just mark the whole problem wrong. Since they clearly don't understand, you need to find the x and the y. That way you can get that ordered pair that you see right here. Okay? So always remember, if you find the x, you've got to find the y. And if you find the y first, then you got to go back and find the x, right? You need both. So let's look at number 3. X minus 6y equals 13. And negative x plus 4y equals -7. So here I'm given two different equations, and the first thing I need to do is I need to get x by itself or y by itself, and I can use whichever equation I want. Now I think that the top one is going to be a little bit easier for me. So for the top one, what I could do is I could add 6y to both sides, and that'll get this x by itself. So let's do that. I'm going to rewrite it over here, and I'm going to add 6y to both sides. Add 6y. So that way I get x equals 6y plus 13. So now I've got x by itself. I know what x is now. X is 6y plus 13. So I can use that to plug back into the bottom equation. So let's try that. The bottom equation is negative x plus 4y equals -7. I know that x is the same thing as 6y plus 13, so I can replace this x with a 6y plus 13. And notice I'm doing it in parentheses with the negative on the outside, but I'm keeping everything else the same. So I still have the plus 4y equals -7. And then I just start to work it out. Now I know I can distribute the negative. That's going to give me -6y minus 13 plus 4y equals -7. And then I can add the y terms together. So what are my y terms? The -6y and the positive 4y. And now these two y terms, I can put those together to get -2y. But everything else stays the same, right? I still have that minus 13 equals negative 7. All right. So now I've kind of simplified it down a little bit so that the y terms are put together and then the numbers can go off to a side by themselves. So now to get y by itself, I would need to get rid of this negative 13 and this negative 2 right here. So how could I do that? Well, to get rid of a negative 13, we add 13 to both sides. And I'm kind of running out of space here, so I'm going to go over here. The negative 2y comes over, but these 13s are going to cancel each other out. And 13 minus 7 is going to give me 6. So now I'm ready to solve for y. I can get rid of this negative 2 by dividing both sides by negative 2. And that's going to give me y equals negative 3. So now I know what y is. But then I have to figure out what x is so that I can complete that ordered pair xy. So I could plug back into the top equation, or I can plug back into the bottom equation. And no matter which one I choose, my x value and my y value are always going to be the same, no matter which line that I choose, the top or the bottom. So for this one, since it really doesn't matter which one we choose, let's choose the top equation. So here I'm doing back substitution. I'm going to change my color to red. So my bottom equation is negative x plus 4y equals negative 7. So now, since I know that y is negative 3, I can just plug that in for y. So keeping everything else the same, I get negative x plus 4 times negative 3 equals negative 7. So simplifying that a little bit, I know that 4 times negative 3 is going to give me negative 12. And then I can add 12 to both sides to get rid of that. And I get negative x equals positive 5. So then to get the negative away from the x, you could do two things. You could divide both sides by negative 1, or you could do what I'm doing. You can multiply both sides by negative 1 and get that same result. So then if I multiply by negative 1, I get x equals negative 5. So now I know what my x is. My x is going to be negative 5. And I know what my y is. My y is going to be negative 3. Okay. So you're choosing one line. And once again, it doesn't matter which line you choose. I chose the top one. And I chose to solve for x. I took what this was and I plugged it in. And then eventually I got to the point where I figured out what y was. And now if you know what y is, you can always figure out what the other variable is. Okay? Let's look at one more like that. All right. So for this one, I'm given two equations. I get negative 3x minus 7y equals negative 5. And then down below it, I have the second equation. I have negative 2x plus y equals negative 9. All right, so when I substitute, what I want to look for is I want to look for a very easy variable to solve for, whether it's x or whether it's y. Doesn't matter. I just need to figure out one of these first. And I see that y is almost already by itself in this second equation. So I want to get y by itself here. That way I can plug back into the top equation. So how could I get y by itself? Well, I would have to get rid of this negative 2x. So how could I do that? I could add 2x to both sides. That would neutralize the negative 2 and the positive 2, but realize I would also have to do it to this side too. So I get y is equal to 2x minus 9. So now I know what y is. And now I'm free to plug back into the top equation, which is what I'm going to do next. So I have the top equation being negative 3x minus 7y equals negative 5. I know that y is the same thing as 2x minus 9, so that when I substitute back in, I can replace this y with a 2x minus 9, letting everything else stay the same. Okay? So all I did was I replaced this y with a 2x minus 9. And now I can simplify a little bit, right? This stays the same. And I can multiply everything on the inside by a negative 7. I get negative 14x plus 63. And then I bring down the negative 5. So now I can simplify a little bit more, right? I can get all the x terms together. If I put the negative 3 with the negative 14, I'll get negative 17. Everything else stays the same still. I've got negative 17x. I have a positive 63 and a negative 5. Can I get rid of the positive 63? I can only if I subtract it from both sides. See how that kind of neutralizes the positive 63 with the negative 63? So these are going to cancel out, while all the numbers are going to move over to the right side. So putting all of those together, I get negative 68 on the right side. And then I can divide by negative 17 to get the x by itself. And I get x equals 4. So now I know that x is positive 4. I finally got a number for one of my variables. So up here, where I said x is, I don't know, I can replace that with a positive 4. What is y? Well, I still don't know that, so I've got to leave the question mark. But I can always substitute back into whichever equation I want, right? Either the top or the bottom. So this time I'm going to choose the bottom equation because it does kind of look the easiest. So let's rewrite that, keeping everything the same. I know that x is the same thing as 4 from down here. So I'm going to replace this x with a 4. So I'm substituting in 4 for x, keeping everything else the same. Negative 2 times 4 will give me negative 8. Everything else stays the same. And now to get y by itself, I need to get rid of this negative 8 somehow. I would add 8 to both sides. And I get y equals negative 1. So now I've got a number for x. I've got a number for y. So I can write my ordered pair, putting x first and y second. So if I solve for x first, I need to go back in and back substitute to figure out what y is. But let's say I actually get to y first. Well, then I would have to back substitute y in to figure out what x is, because where there's an x, there's a y.